So hello everyone, welcome back to our C++ for OpenFOAMers. We're going to use Linux. Thanks for watching the last, thanks for bearing with me the last few videos, going through some really dry stuff. I'm trying to spice things up by giving examples. For example, the Reynolds number. At least you can see what some of these functions can be used for. Alright, so now we want to do something slightly more complex. So we want to start looking into for, if, and while loops. That's where we want to go next. And why do we want to do this? Well, we know that in a solving of equations, we all have vectors, right? So 1, minus 1, okay, 1, minus 1, and minus 3. Alright, for example, we have a vector like this. And then let's say we want to find the length of this vector. Normally what we need to do is, first thing, we need square root, okay, 1 square, plus minus 1 square, plus minus 3 square. Okay, so of course I can type this out in Microsoft Word. It'll be pretty much the same thing. And okay, so this is one of the things we want to be doing later, but let's go with vectors first. Okay, so I'm going to type 1, minus 1, and 3, and let's say we want to find the magnitude. So I'm going to put a semicolon, I'm going to copy this and paste. Alright, so I just press enter and then it'll give you this vector kind of thing. So I need a square root, and remember, equation editor, I use alternate and equal to get me into that equation editor. Okay, so that's 1 square. I think I need to do something. Okay, 1 square plus minus 1 square plus minus 3 square. Alright, so very simple algorithm. We want to find the length of a vector. So let's start from the basics first. Alright, we need a CMath function. Okay, so let's go to functions and let's make a cp Reynolds.c++, and I want to name it as maybe some vector length.c++. Okay, so we have a vector length, right? Alright, let's go and edit it. Alright, so again, for a vector of, let's say, three what do you call that? 3 coordinates, x, y, and z. We can do it like so. Vector length. We can call a function called vector length. We can have double x, double y, double z, and this extra one I don't need it, and I'll save it. And I want to declare 4 variables: x, alright, x, y, z, and l being the length, of course. So I want to declare 4 variables, and I ask the user to input x, y, and z. So instead of density, I will ask them to input x. Okay, I'll input x. Okay, I'm just going to ignore all the standard things down there. I mean, we discussed that in the last video, what it is. So in the next one, so after inputting x, we will input y. So let's just delete this, and we'll put y. Now I just delete this and put y. Then let's have a z. Input z, and you have a cin of z. And these 2 lines you can delete because they are redundant. 1, 2. And so instead of Reynolds number, I want to calculate some vector length. Okay, so the length is, that's just a print line. Okay, so I will have vector length x, y, and z. Okay, vector length x, y, and z. Alright, so that's just is a vector, 3 and 1 and 3 vector.
Really?
Yeah, I was like, what are these papers?
Yeah, it's a vector of 3 rows and 1 column, and then it calculates the length. Okay, but in this case, that you're just inputting the elements of the vector x, y, and z. So okay, I'm gonna copy this from the top. Oopsie. Copy this from the top.
We have a standing, agreement that, that like this is a communal space, so.
Anyway, so I copy and paste this down here, and I need to declare a variable L. So I'll say L is equals to
So I uploaded a folder to
square root
Google Drive.
power
And I'm going to
x
share it with you.
to the power of 2.0 plus power y to the power of 2.0
Odd
plus
to
power
dot and
z to the power of 2.0. Alright, and then I need to return L instead of Reynolds number, and this will need to return L. Okay. Alright, so that's what I have so far. Hopefully it calculates the vector length given a x, y, and z.
has those articles.
So let's g++ vector length.c++, the output of length calc. Okay. Okay, thankfully there's no error. So let's try running length calc. So 4, 4, and 4. And the length is 6.292. 6.9282. Let's pull out our calculator. So 4 square plus 4 square plus 4 square. That's 48. So square root of 48 is 6.2982. Now this is simple enough, right? Simple enough. But what happens if you want to do other things with this? Let's say you have an actual vector. All right, now you're just putting in the elements of a vector. All right. Let's say you put in a vector. How are we supposed to do that? Yeah. So how can we generalize vector addition in C++? So instead of putting x, y, and z, for example, let's consider how we can use an array in C++. So arrays are, they are kind of variables that store more than one value. In this case, we want to store double values. Okay, so they go by this convention. So the first row is called 0, second row is called 1, third row is called 2. So it starts from 0. So column 0, 1, and 2. And how do we declare an array variable? Okay, so we have to specify, okay, in this case integer, and then the name of the array, and how many in the x direction and how many in the y direction. Okay, so yeah.
I'll just put this article.
So where is x going? X is you start from the rows first, then the columns. So x equals 0, x equals 1, x equals 2, y equals 0, y equals 1, and y equals to 2. Now this is kind of a bit inverted from our usual graph notations, but this is pretty common when you deal with matrices. So x is not the horizontal anymore, x is the vertical, because we start with columns first. So that's just something to take note of, and we will try to implement this into our C++ code. Okay, so instead of this, let's go and vi our vector length.c++. So Okay, let's try doing something a little different. In our main file, we don't have a double anymore of x, y, and z. Okay, we have this. We have a double array of vector. Okay, and we'll give it 3 in the vertical direction, 1 in the horizontal direction. So let's see whether this works. Okay, so this is how we define it. The name of the array, or in this case our vector, how many in the x direction, which is the vertical direction, how many in the y direction, which is the horizontal direction. So this is how we can declare a vector. Alright. Alright, so how can we then do something about, putting in the x, y, and z values into this vector, this array. So how do we put the elements of the arrays in? So according to this website, we can see if we want to initiate this 3-row and 4-column array, 3-row, 4-column array, the first row will be like so: 0, 1, 2, and 3. So let me bring up Paint.
If you want this notebook, I mean, it's not very.
If you bring up Paint, the first row is 0, 1, 2, and 3. 0,
I have some.
0, 1, 2, and 3. That's the first row. Second row, 4, 5, 6, 7. 4, 5, 6, 7. And the last row, 8, 9, 10, 11. 8, 9, 10, 11. And then you close up. So this is what the array will look like. Okay, so what they do is, they use this nested braces, to help the user see, right? So the first column is like that, 0, 1, 2, and 3. Second column is like that, 4, 5, 6, 7. And the third column is like that, 8, 9, 10, and 11. 8, 9, 10, 11. So this way, it's very easy for us to visualize making an array of numbers, or in this, which can represent a matrix. Okay, so what can we do with our vector? How can we then get our vector? All right, our vector can be defined like this: vector, 3, 1 equals vector 3, 1. So the first row, curly brackets. With curly brackets, we still need the semicolon here. Alright. The first thing we'll need to have is the x. X will go on top. Second will be y. Third will be z. So this is just following the format as put here. So it's following the format as put here. And then it will need to calculate some length. Alright, so in the next video, we'll talk about how to access the elements of the vector, elements of the array rather, to calculate our vector length. Alright, of course this algorithm still works if we just put x, y, and z, but we want to put in arrays so that we can start using the code, to add vectors and everything. So, and that's very important in our CFD or ODEs or PDE kind of calculations. So see you in the next video.